In this lecture, I'm going to teach you about the properties and characteristics of radioactive rays. First of all, how can we just occur the radioactive ray? So, the best form to just release the radioactive ray is formation or the breakage of U2O3, that is an radioactive compound. We can also take another radioactive compound, but the best way to occur the radioactive rays as radioactive compound. Just see, this is an electric field. Now, between the electric field, we're gonna pass out the radioactive rays from the hole in it. Like there is a very small hole in this lead box. Let me tell you, this is a lead box. Radioactive rays can only be isolated by the lead box. Secondly, when we're gonna pass, this is an electric field. Let me just write it to EF. It is an electric field. So, in the electric field, when we're gonna pass the radioactive rays, it will split. Like, first it will go to the positive side, that we call it the beta rays, because the beta rays has minus sign, so it is attracted towards the positive node. And secondly, the alpha rays. Other all remaining rays will go there. Now, how many rays we get? We get 3 rays: alpha rays, beta rays, and gamma rays in the form of the energy. Gamma rays do not have mass, do not have any property, so it is in form of energy, so it is also released, but it cannot be identified. First of all, let's talk about the properties. First, alpha rays. I have written alpha rays in the starting because alpha rays is the most heavier. Like alpha rays are heavier than the beta rays, and beta rays are heavier than the gamma rays. How? Let's identify or tell that with the properties. So first of all, what are alpha rays? Alpha rays are helium nuclei. During the discovery of the alpha rays, the electron of alpha rays just kicked out, but what left? We left with the two proton and 2 neutron. So that's why we just say that it's an helium nuclei. The beta rays are fast moving electron. Fast moving electron also got MV. The inertia of beta rays are more because it has the most inertia, but here the condition of the beta rays is that it is fast moving. So the momentum of the beta rays are the most. Inertia is the alpha rays most. As compared to gamma rays do not have any momentum because it does not have any mass. That's why it does not have any momentum. Likewise, let's talk about the mass. The mass of the alpha rays are 4 AMU. 2 proton, 2 neutron, 4 AMU. The mass of the beta rays is 9.1 10 raised to power 31 kg. Now here, this is also mass of the electron, and as we know that the beta rays are fast moving electrons, so the mass of the electron is given here. Third one, let me tell you first that what are gamma rays. I will skip that, sorry. And the gamma rays are electromagnetic photon. Electromagnetic photon, it does not attract either with the magnetic pole, neither with the electric pole. That's why it is called electromagnetic photon. It is the purest form of the energy. It is an immaterial. Immaterial means it does not have any mass, not any charge. So it is not any material, but still it's an energy, photon. Secondly, the mass of the gamma rays is nothing. It does not have any rays. It does not have any mass. Thirdly, the charge of the alpha rays are double positive. Double positive because there are two protons, so it is double positive. Now, if the charge is double positive, so the charge value would be, now we know that charge is measured in coulomb, that's why it's written C here. Now the value of the charge here is 3.2 10 raised to power 19. Now we knew that the actual charge value is 1.6 10 raised to power minus 19. So it is added. Let's add it. 1.6. 6 and 6, 12. Now 1, then 1, it becomes 3. Now this point would also be occurring here. Now that's why it becomes 9 10 raised to power 19, 3.2. Okay. Now let's talk about the charge of the beta rays. The charge of the beta rays is equal to 1 charge. As we added 2 double charges, so we occurred that 3.2 10 raised to power minus 19 coulomb. But here there is only 1 charge. So it is 1.6 10 raised to power minus 19 coulomb. Now you should know that the charge individually has a constant value of 1.6 10 raised to power 19. Here is 1 charge. That's why it's written that 1.6 10 raised to power 19. Now, gamma rays do not have any charge. Fourthly, the penetration of the alpha rays is low, the beta rays has moderate, and the gamma rays has the highest. Now, the penetration depends on the mass of the rays. Depends on mass. Penetration is equal to inversely proportional to the mass. How? If the mass increases, the penetration would decrease. If the penetration increases, mass would be decreased. Okay? How? Just see, these are 3 ways in which this is the thinnest, this is much thick, this is the thickest. So, when alpha rays pass in it, it will only coincide here and it will go down. As compared to beta rays, it will go there and then it will fall. But gamma rays will pass all these because it does not have any mass. That's why. Okay. Last but not the least, ionizing power. Now we know that ionizing power means the power to ionize the atom. Now the atom is ionized by the hitting or just changing the sign of the electron. Now the ionizing power of alpha rays is 100 times greater than the beta rays, or we can say that it is 1/10 of the speed of light. Like it moves with the 1/10 speed of light. It is speed. Now, when alpha rays are coincides with the electron, or we can say that atom, it has the most ionizing power because we know that alpha rays are double positive. So, it coincides more. As compared to beta rays is 1000 times greater than the gamma rays, but it's less than the alpha rays. It is the 9/10 of the speed of light. It moves fast, but still it has less ionizing power. The gamma rays has the most ionizing power as it hits the atom most. So that's why it has the least ionizing power, because it does not have the mass or charge. That's why. And it moves with the speed of light. And that's all about today's lecture.